Greetings, guys. We're going to do a little bit of factoring here. Yeah, a little bit of factoring. It says here, factor each trigonometric expression. But you know what? 15 and 16, there's some tricks to those, so we're not going to cover those yet. And then problem number 22 here, just so you know, I'm going to do this one as an example because if you look next to it, right here, you will see that there is something very similar to it I would like you to attempt. But you'll also see I have this other section here. So what I'm going to ask you guys to do when we're done is, this is from our book, page 202, 13 to 34. We're going to skip 15 and 16. Those are the ones I have crossed out. And then you'll see I've done some as examples. But first off, the top section right here, this section right here, is all about factoring. So let's factor some stuff. Here we go. I'm going to scroll on down. Oh, by the way, there is an answer key. We'll talk about it when we need to. But let's talk about some factoring tricks. See this guy right here? Tangent squared minus 1. Well, tangent squared minus 1. Ooh, that's tan and 1 sec. No, it's not. Remember, there are some things that will try and mess your mind up. This is not tangent squared theta plus 1. It's not. But I'm hoping that you guys see the similarity to things we have done before. Like, if this was x squared minus 1, it would be the differences squared. Well, pretend that's not an x. Let's pretend that's tangent. So guess what? Instead of x plus 1, x minus 1, we're not doing that. We're doing tangent theta plus 1, tangent theta minus 1. This thing could still be the difference of squares. It could happen. Trig is amazing. All the little stuff that's embedded in it. So we're going to do tangent theta plus 1 times tangent theta minus 1. That's the answer they want, by the way. In this first section, it's just factoring. So let's move down. See this guy right here? You're going to run into one that's very similar to this. And you say, oh man, well, this has secant in it. Yeah, it does, but that's okay. You've seen problems like this. You've seen stuff that looks like 2 something squared minus 5 something minus 3. You've seen this kind of stuff. And what would you do? If I wanted to factor this, I'd still try to break it up and say, well, 2a times a, right? I would have a strategy. Well, guess what? I'm going to use the same type of strategy down here. The only difference is I don't have just a single variable here. I have this trig function, but I could still do 2 secant x times secant x. If I did that, I would get 2 secant squared x. Last sign's minus, the same stuff. Oh, it's got to be opposite signs. Maybe that's a plus, maybe that's a minus, maybe I have to switch it around. But you know, there's only one way I can write 3 using multiplication, 1 times 3. So I either put the 3 here and the 1 here, or I switch it around and I put the 1 here and the 3 here. And let's just see what we get. See, I picked this to make that part come true. I pick this to make that part come true. But let me get some of this stuff out of my way so we have a little less noise to deal with. But in the middle, that's where I'm going to check it. 1 times secant, that's just secant. Ooh, 2 secant times negative 3 is negative 6 of them. That's what it is. That's how it works. Grand total, 1 secant, take away 6 secant, is negative 5 secant. What? There it is. It's tremendous. Es la verdad. Factoring tricks. What we're doing is factoring. They just happen to take away the variables we're used to, and they stuck secants or cotangents or what? Oh, tangents. Sometimes they put tangent in there. And you go, wait a minute, I don't have nothing that is a tangent 4. We have done this. It's just been a long, long time ago. See, I know if I did tangent squared x times itself, I would get tangent fourth x. I would. Don't let the problem intimidate you. And then look here. It's either, I got to get a 4. So I could say maybe plus 2 and minus 2. I could maybe. But you know what? Maybe that's not the way to go. Because if I check that, I would end up with 2 tangent squared, take away 2 tangent. Oh, that's not going to do it. So the thing is, what I'm trying to say is, they didn't change the game. They just changed the ugliness by putting stuff in our way that looks scarier. Don't be intimidated. I'm still going to say 1 and 4 maybe here. Yeah. Hear me out. This times this, that would give me tangent to the fourth. That's good. And then 1 times negative 4, that would give me negative 4. Yeah, it would. So let's check the middle. 1 times that would be 1 tangent squared x. And then on the outskirts of town here, negative 4 times that would be negative 4 tangent squared x. Grand total, that's a negative 3. Oops, and that's what I wanted. So guess what? Let's get rid of some of this noise. Let's get rid of some of this stuff. It's just in the way. What happened? Well, I took this problem and I factored it, and I got that. Factoring tricks. Now, before I go to the last little factoring trick, let me scroll up. This part right here, the top part from 13 to 22, that's just factor it. I skipped the 2 weird ones, but I'm going to do number 22 as an example because I want you to look at that. Looks like a plus sign, and it looks like something else. What do you think I'm going for here? What do you think I've got in my bag of tricks? I hope you're thinking cube formula. So guess what? I'm going to go down and grab me this last example about factoring stuff, and I'm going to call it Revenge of the Cubes. It is problem number 22. And I say, oh, what times itself 3 times is sine cubed alpha? That's a cool looking variable called alpha. It's like if you drew an X, but then you connected those 2 parts of it. Actually, that looks really bad. But this guy right here, this guy is called alpha. That's an alpha. So what do they want from me? Well, I'm going to go, you know what? Sine alpha times sine alpha times sine alpha would be sine cubed alpha. And in the formula, they call that thing A. And then what times itself 3 times would be cosine cubed alpha? Well, cosine alpha times cosine alpha times cosine alpha. That's what they call B in the formula. And I keep preaching my flashcard idea where I say, you know what? These formulas, hey, they keep coming back at the strangest times. They do. And if you have it memorized, then you go and you get it and you plug it in. I kind of scribbled that down really quick while talking, so it's a little bit messy, but it's going to get the job done. Remember, if I have something cubed plus another thing cubed, I can plug it into these 2 sets of parentheses. So I would say A plus B, then A squared. So what's going to happen when I put that in there and square it? Well, I'm going to get sine squared alpha minus A times B plus B squared. Well, that's just going to be cosine squared alpha. Ooh, let's make that a little prettier. A little bit prettier on the outside there. Okay. But that's not the answer. See, when you look up the answer to this one, you're going to see this part. You will. But you won't see this whole big chunk here. You know what you're going to see? You're going to see 1 minus sine alpha cosine alpha. Well, heck, how did they do that? Look at this magic. Watch this magic right here. Check this out. See this guy? That guy plus this guy? These two dudes go together, guess what you get? Sine squared alpha plus cosine squared alpha is 1. Es la verdad. Es igual a 1. It's equal to 1. We're putting that right there. Now, I'm not lying to you. Take a look at the answer to 22. Look, let's go back and look at this key. There's the answer to 22. I totally told you that. That's crazy. Isn't that crazy? Now, this is the answer key for all these problems. So here, you might as well pause it and take a picture of it. Here's the key for the top part. This is just the factoring section. Then, this section right here is very similar to the section we just did on page 195. This is extremely similar stuff. The only difference is the way they worded the instructions. So I want to make sure that you get this. Sometimes half the battle is understanding what they're actually asking for. So let me scroll up. This section right here, 23 to 34. Now here's the deal with this. It says each expression simplifies to a constant, a single function, or a power of a function. Once again, like we did on page 195, you should probably have this answer key on your phone. Take a picture of it right now. And then when you're doing those problems, check and see if you match. It's going to make it so much easier. All right, so let's take a look at a couple problems like this. Oh, I passed the one. There it is. So, constant single function power of a function. Okay. Constant. That's a fancy way to say number. Like if you work it out and you clean it up and everything and your answer is 2, that's called a constant. I cleaned it up and I got 1 for an answer. Well, 1's a number. We call it a constant. Single function. Ooh, what does that mean? Well, it means your answer is just simply cosine. Cosine x. Or maybe you got tangent. Tangent beta. That's an example of what a single function answer will look like. Then power of a function, well, what the heck? Let's just do this first example and you'll see what I mean. So this first example, they give me this weird fraction-y thing, and they say, can you write this as a constant, a single function, or a power of a function? Well, here's what I'm going to do first. I am going to say unto ye, this could be the same thing in the top as cosine beta times, well, what is cotangent? Isn't it the same as cosine beta over sine beta? And by the way, that's beta. That's another Greek letter. But that's just the numerator of my fraction. This is still in the bottom. Well, you know what? Let's try and make this a little prettier. I'm going to say this times the top times, so I get a cosine squared beta over a sine beta. That's what I get in the top, but don't forget, we have this guy down below. What? Yeah. So we have this stuff divided by this guy. You mean I have this stuff divided by this guy. That's what I have, don't I? Well, I could flip and multiply. I could just flip, and multiply. And if I did, I would have cosine squared beta over sine beta times 1 over sine beta. Oh, wait a minute. Let's just multiply it. Cosine squared beta times 1. That's what I get. On the bottom, sine beta times sine beta. I'd get sine squared beta. And then I go, wait a minute. Wait a minute. I recognize this guy. This would be the same thing as dot, 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 dun, dun, dun. It would be the same thing as cotangent squared beta. That's the answer. That is what they mean by sometimes your answer will be a power of a function. If you get like tangent squared something or sine squared something, that's what they mean by power of a function. So once again, before we do any more, take a look at the answer key for that section. Just take a look at the answer key for that section. All of the answers in this section turn out to be a single function. So like number 24, I'm a single function. Or a constant. Hey, look at number 26 and 25. Those are regular numbers. Those are called constants. And then power of a function. Hey, pretty much 27 till the end, everything turns out to be a power of a function. So I am going to knock off two of them for you. Here we go. Let me go down. Whoop, there it is. Here's the next example I wanted to do. Number 31, okay? But before I do that, you know what? Anytime you want, you can jot this stuff down. You can take a picture of it. You can make this your own. Put it in your scrapbook, okay? This next one, though, believe it or not, is less work than that one. And it looks more complicated. Well, here we go. It all depends on the way you see things. See, I'm looking at this thing right here. And I'm thinking of it just like I did the last time. Hey, sine squared x over cosine squared x, to me, that's tangent squared x. Plus, well, let's break this down. This guy right here, what is he? Oh, he's just 1 over sine. So what they have here is they have sine x times 1 over sine x. That's what this guy is. And what can I do with that piece of... Oh, let's cancel that. So I get tangent squared x plus 1. Now that's 10 in 1 sec. Boom. Holla. Number 31, that's the answer. You can check it. The answer key is there, but that's the answer to number 31. Now I did that because answer to 32 is very similar. Let's take a look at this one. Guess why I'm doing number 33? Because you're going to try number 34, and then you'll be done with this assignment. So we are almost at the point where we're going to play big time with some identities, but we had to get through a couple days of just kind of noodling around and playing around. And while I'm looking at this, that guy right there is sine squared x. When we went through the very first video, we know that this is, whoops, sorry, I did that backwards. I was trying to talk and write at the same time. Let me do it the right way. I know that this is this thing. I know this is true. I also know, hey, what if they square this? Well, then this is true. But this was from our first lesson. I said, don't forget, there's different ways to organize this information. Oh, I'm going to take that and say, you know what? We are the same dude. So if I were to substitute, right there, guess what I would end up with? I would end up with this thing saying 1 minus sine squared x. And you might look at that and say, I have no idea why you would want to do that. And I'm going to remind you that there is something that looks like this in the world. If this was over there, boy, if this was over there, guess what this thing would equal? Cosine squared x. The hardest part of this entire class in my book, in my opinion, is this week. This is where it's going to be tough because you have to really practice. And you may not always succeed. And if you do not always succeed, guess what? Guess what? you're gonna have to try again. But try in the Zoom room with me. Hey, that's a good way to do it. You could sit there, just park yourself down with a trig book and I don't know, a Dr. Pepper, or maybe not a Dr. Pepper. I don't know, it sounds really good to me right now. And try to get through these problems. And if you get stuck or you have a question, I'm right there. Alrighty, so guys, let's call it a day. We'll move on to the next one. Okay, bye-bye.